Hello my gravy babies, how are you guys doing? Unfortunately, I was feeling a little bit sick the other days, so I didn't film too much. But today we're back with the JSI guide explained. So, before I start, I would like to thank all of you once again for watching these guides. Unfortunately, it looks like the audience is rapidly falling, so this is going to be pretty much the last video I'm going to do. And I'm going to cover pretty much all the technical details about the specific implementation I did for SQLite. Now, that being said, I will probably do one more video about the Android bindings, but to be honest, it's not super necessary because a lot of the setup, as I stated before, it's going to change anyways once the turbo modules are completely released into the public. So I don't know, I'll see how I feel and if I do it. Now on this video, like I said, I'm going to go into the very technical details of implementing a SQL library, but to be honest, I am going to pretty much just copy and paste a lot of the existing code. Otherwise this video will be 2 hours long and that's just too damn boring. So anyways, before I start, I actually wanted to answer one question that I got on Twitter the other day, which I found really interesting because there seems to be some confusion about the JSI and what it can do for you. Somebody asked me, or somebody tweeted at me that, and it said, I've been playing with the JSI these days and I missed something I've not been able yet to find. On JSA, JC or V8, we can store references to native objects in JS values native counterparts. For example, JSC private data. Any clue how to do with the JSI? And I think there's some misconceptions in here about how the JSI works or what actually is the JSI. I would recommend, if you have this kind of high-level doubts, to go back and watch the first video and pay a little bit of attention. But just to be clear, just because the JSI exists doesn't mean you can throw any type of native object or code at it and it will automatically make it available on the JavaScript side. It doesn't work like this. It's more as, you have to think about the JSI more as a communication layer between JavaScript and, you know, whatever native language you're implementing. You cannot just give the JSI a pointer to a native object and expect JavaScript to be able to know how to deal with this memory chunk. It doesn't work like that. You have to convert your native values into JSI values, right? And by converting them into JSI objects and values, then JavaScript can interact with them. So it's really a communication layer. It's not magic, automatic magic to interact with the native side of things. Awesome. Now that I have answered that question, let's go over how would you actually implement a SQL library on React Native. So this is also something another person asked me the other day, which is how would you bring a native library into your JSI module. I'm going to show you what I did. Probably is not the correct way or not the best way to do things, but I'm pretty retarded and this is how I got it to work. So if it works, it will work for somebody else. So as stated, we want to use SQLite. Now, in order to use SQLite, you need to get your hands on the SQLite source code. So if I would go to Google and just search for SQLite source, then I would be redirected into the SQLite site, and here it points you to, you know, its version control system, and somewhere in there you will find a zip archive. If you download this zip archive, let's just download it and see what's inside, just to have fun with it. So once I have my zip archive in my machine, it will decompress, and you'll see that this is all the stuff that SQLite has. Now, this is not very good for us, right? Because it's just too much. So what I could do is just try to copy everything into my Xcode project, into my CPP directory where all my C code lives, and then, you know, try to somehow get the compilation working. This doesn't really work for us. So instead, what you want to do is look for a different type of source code or binaries where they're called the amalgamation. Not all the libraries will have this. Some will do, some will not, but the amalgamation of the source code is basically all the source files concatenated into a single file of C code, right? So this is a lot easier for us. You can again go into the download side of SQLite, and here you have the SQLite amalgamation. Once you have downloaded that, if you go to, or let's go to the downloads directory, I have it here. It's a lot simpler. You basically have a C file and a header file. These two are not really necessary. We only need the source code and the header file. So basically this is how I did it for SQLite. It makes it quite easier because SQLite is kind of designed to be embedded into other systems. Now, depending on your library, it will be different. That being said, on Android, you can have pre-compiled libraries with Java bindings, right? So this is what they're called, the AAR files. I could use this, but this is not really what I'm looking for because I don't want Java bindings, right? I don't really care, since I'm going to call this from the C++ code. I can just use the amalgamation file. That being said, on some of the libraries, by having a precompiled file, you will gain performance when you're packaging your application because you don't have to compile the source code, right? It's already compiled, so you can just include it. You can also generate your own AAR files. To be honest, I'm too stupid to do it because I'm not a native developer and I don't really care. So if you want to get the best performance when compiling your C++ module, this is something you want to look at. Let's get into the source code very quickly because otherwise we're gonna run out of time. Now, like I said, I'm not going to go over every single detail. What I'm going to do is I'm just going to go over the source code of SQ8 QuickLite. This is the final library, which already I have published. And I'm just going to copy some chunks of this in order to explain it to you, in order to tell you how I did it. Now, let's copy, first of all, this function. And let's go back to our code. So last time we left here with our multiply lambda, right, where we explored all the different JSI values that we had. I'm going to get rid of this, and I'm just going to paste, oh god, Xcode. I'm just going to paste the code that I took from the library. And let's go quickly over it. Once again, this is a lambda function where I am creating my JSI function based on the C++ lambda. What this function is supposed to do is, if you have a database, you need to open a connection to your database, right? This is the same in Postgres, MySQL, etc., etc. So basically what I'm going to have in this entry file are going to be all my basic functions to interact with my library. Here inside of the open function is fairly straightforward. I am making sure that I get at least one, or I get arguments for my open function. I'm checking that they are the correct type. We're gonna go over this in a little bit, but for now, let's say, you know, I'm just getting all the arguments for my function prepared. And then finally, at some point, I am just going to call a SQL open function which is what we're going to take a look in a little bit. This is the function implemented in pure, let's say, pure C that doesn't know anything about the JSI, that will talk with the SQLite, pure implementation, and open a connection to a database. So then we can execute SQLite against that database. So nothing too special, right? And I'm just creating a JSI function that will be the function that I'm going to be able to call from JavaScript. So here you see I have other functions. I'm just going to take and copy them, which are going to represent all the options. Oh, I hate Xcode. All the options that I want to have when dealing with a database. I want to close a connection to a database. I want to delete a database. I want to execute SQL against a database. This function I don't need. I'm just going to remove it. And then this is something different from what you will see in the most basic tutorials. Instead of directly creating functions on my global object, I basically just create a module or an object. And inside of that object, I am inserting these functions. I'm inserting the open function, the close function, the delete function, and the execute SQL function. And then I'm binding that object into the global context. Right? So instead of directly calling open, and then, who knows what you're going to call with open, you have to do SQLite, in your JavaScript code. This will be SQLite, yada, 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 to open a connection to the database. Now, before diving into the SQLite code, let me show you one helper structure that I created and that I found really useful. I'm just going to go into my C++ folder. I'm going to create a new file. This is going to be a C++ file. And this is going to be, what's the name of this thing? 1 second, SQL result. Yes. Or I don't remember if it needs to be a, yes, it only needs to be a header file. So we are going to get rid of the implementation file. Yeah, sure, move to trash. Again, I want this to be a header. And inside of here, I have a struct. So you might be wondering, what am I doing? So basically, I kind of took a shortcut, right? Because like I said, the JSI is not magic when you deal with native code. You cannot just pass anything to it. You need to create JSI objects based on your C++ code. So at some point when I first implemented the library, I tried to separate all my C++ code that dealt with SQLite and all the results that SQLite gave me. And then at some point translating those results into JSI values. Now this kind of presents a problem because let's say, for example, SQLite will return me an array of results. So what happens if I have these two implementations completely separated? Then it means that I'm going to kind of have to do a lot of work for copying all the native values into JSI values. And sometimes this is fine, right? If you have very little objects and you don't really care, then you won't pay a large penalty. But since we're dealing with SQLite and a database, and I want this to be as robust as possible for very large applications, then I would probably spend a lot of time just copying stuff or creating JSI objects, which is not ideal, right? This is a lot of duplicated work. So what I did, I got a little bit smart about it, and I created this wrapper struct, right? It's not a complete class, not a complete object, but it just kind of helps me to do a certain SQL operation. And then inside of it, I already have a JSI value, right? So whenever I try to execute an SQL string into SQLite, I will just directly be creating JSI values in order to return them as soon as possible to JavaScript. So this is basically what it's doing. It's just a wrapper structure. Ooh, we're already 50 minutes in. Okay, we need to pick the pace up a little bit. So the next thing that I need, I'm just going to copy this, and this is the big file where I implemented a lot of the logic when dealing with SQLite. I am just going to create a C++ file, and I will just call this SQL because I am not very creative. Once again, I will just get rid of this, and here now this is very dependent on SQLite, right? This will not be useful to you if you're dealing with any other library, but in any case, what I wanted to show you is some of the tricks that I did to make this work nicely with the JSI. So for example, you know, here we have the SQL open function that we talked when we went over our binding. So this is our JSI binding. You know, after I do the validation of the parameters that I get from JavaScript, then I finally call my native function that actually opens a connection to a SQLite database. So here's where I put this function, right? And here, you know, this is very SQLite dependent code. You will need to read the documentation of any library that you're trying to bind. This is going to change and it's going to have quirks, so you know there's nothing I can do to help you. But here is one of the interesting parts. So right, so after I call the native function SQLite open v2, you know, this is the default function to open a SQLite database. This returns exit code to me, right? So instead of saying instead of directly returning, you know, a boolean or something, I use my helper struct to kind of return ready to consume value for JavaScript. So in this case, you know, I wasn't able to open the connection, and I don't know why, right? So first I return the type of error, then I get the string, the error string from SQLite, and then finally I return the result for JavaScript from my operation. So then on my binding, I basically just check, you know, if my result, if the type of my result is of the type error, then I can throw directly a JavaScript error. If not, then I can just move the JSI object that I create into, directly pass it into JavaScript. So like I said, I cheated a little bit because this mixes a little bit the JSI code with the SQLite code, but this is in order to get the most performance out of my code in order not to repeat operations. So then here you're gonna have, you can check out the code yourself, you're gonna have a lot of very confusing C code that deals with taking JSI values, putting them into the SQLite statement, which has its own logic, etc., casting them into the correct types, if it's an integer, if it's a long, if it's a double, if it's a string, etc., right? So this is very complex. Well, it's not complex, but it's very logic heavy code when dealing with SQLite databases. Now, the last thing that I wanted to show you in this code is, for example, when I execute SQL statement, like I said, I will get some results, right? So instead of keeping my results, returning my pure results into my JSI file and then turning them into JSI values, basically when I am creating when the SQLite engine returns the results to me, I already create a JSI object, right? So per each of the results SQLite gave back to me, what I do is basically I just go creating JSI values, and then, you know, I'm basically creating an array of JavaScript objects. So then finally, when the time comes, I can just create a static array, and then, you know, just kind of move all the stuff into that array, put that into an object where I put some extra properties that might be useful for whomever is trying to execute the SQL query. And then finally, I can just return that final array or that final object into the JavaScript context. So that's pretty much it, right? It's fairly complex, but that's basically how you would create a C++ library with the JSI. Now there's one small detail, and I'm just going to close this video with it, which are host objects. Now I didn't use host objects because I didn't need them. I don't need to encapsulate any behavior, but host objects. So here, for example, on my JSI bindings file, you can see I create an object, and inside of that object I put some functions, and then I insert that object into the global context. Now this is basically my way of creating objects, but if you would, for example, try to encapsulate some other native behavior, it would probably make a lot more sense to create a C++ class, right? So instead of creating a JSI object with, you know, and then moving the Lambda functions inside of it, you probably wanted to have its own file and, you know, encapsulate the behavior a little bit more clearer. Basically, that's a host object, right? Where you just create a C++ class that implements the host object interface from JSI, and then it basically creates the same, right? It basically creates a class that can be instantiated, and once it's instantiated, it will be just, you know, like any other object on JavaScript. So those are host objects. Great, guys. This video is long enough as it is. So I would like to thank you all for watching the videos. Like I said, the audience for these videos is kind of dying down, so I don't want to spend a lot of time on it yet. I hope you learn a little bit. Like I said, maybe I will explore the Android side of things, but as I mentioned in one of the very first videos, a lot of the setup that I did for the library is just going to change with turbo modules and CodeGen. You will basically just end up writing the code that's inside of your public API, right? All of these Lambda functions will be generated via CodeGen. All the setup of the module will be generated via turbo modules. So all you need to take care of is actually implementing the logic of your module, right? Like making sure you get the parameters, correctly calling your library, correctly coding your C++ code. So anyways, thanks a lot for watching. I hope once again that you learned something, and I will be really thankful if you share these videos with your friends, and if you follow me on Twitter. I try to launch products every now and then, and every little share counts. Thanks a lot, and take care.